Hello to all. Once again, I have chosen a question, Olympiad question, related to sums. Let's read the question. Calculate the sum 1 plus 1 over 1 plus 2 plus 1 over 1 plus 2 plus 3 plus etc. until 1 over 1 plus 2 plus 210. Let's rewrite the question. Let's denote the required sum with S. 1 plus 1 over 1 plus 2, 1 plus 1 over 1 plus 2 plus 3, plus 2, 1 over 1 plus 2 plus until 10. First of all, let's look at the denominators in the given fractions. In the first denominator we have 1 plus 2. In the second we have 1 plus 2 plus 3. In the third 1 plus 3, 1 plus 2 plus 3 plus 4, etc. In the last denominator we have 1 plus 2 plus until 10. One idea is to add all of them and then to make ordinary fractions, but then probably I will stuck on the LCM of all the fractions. First of all, let's notice that this is the sum of the first two natural numbers. The second is the sum of the first three natural numbers, etc. The last sum is the sum of the first 10 natural numbers. Because of this, here I will give one proposition which is very familiar for us mathematicians, but this video is filmed for the younger mathematicians, so they need to learn some new facts. Because of that, let's make here a proposition. So proposition 1, which says 1 plus 2 plus 3, etc. to n, or the sum of the first n natural numbers is exactly n times n plus 1 over 2, for each n in positive integers. So this becomes 3, or 2 times 3 over 2. 2 times 3 over 2. This becomes 3 times 4 over 2. This becomes 4 times 5 over 2, etc. The last sum will be 10 times 11 over 2. This is very important proposition, so I will suggest for the younger mathematicians to learn this proposition. And now we can rewrite the sum in some more appropriate way. Let's do that. So we have S is equal to 1 over 1, or just 1, plus 1 over 2 times 3 over 2, plus 1 over 3 times 4 over 2, plus 3 points, plus 1 over 10 times 11 over 2. And as we know, these are double fractions, so we will have 1 plus. Here we are imagining 1, and these two goes above the fraction line. I will not write this, so this becomes 2 over 2 times 3 plus 2 over 3 times 4 plus etc. 2 times 10 times 11. Let's make one more step. 1 plus 2 outside, and I have in the bracket 2 times 3 plus 1 over 3 times 4 plus 3 points plus 1 over 10 times 11. And now, if we think a little bit more deeper in the bracket, we can realize that this is already well-known sum for us, because this sum was mentioned in our first video. So these are such called telescoping sums. Because of that, I will stop here and make another proposition. So proposition 2 regarding those special terms. So proposition 2. It says 1 over n plus 1 is always 1 over n minus 1 over n plus 1. The proof is very easy. Just put the right hand side under the same LCM, which is n plus 1. Using now this proposition, we will have S is equal 1 plus 2, 1 over 2 minus 1 over 3, that is 1 over 2 times 3 because of the proposition, plus 1 over 3 minus 1 over 4, plus 1 over 4 minus 1 over 5, plus etc. until 1 over 10 minus 1 over 11. As we can see, these terms will cancel out, all of them, except the first and the last one, etc. So we get 1 plus 2 times 1/2 minus 1 over 11. And now let's calculate this. This becomes 1 plus 2, 11 minus 2 over 22. This is 1 plus, let's cancel the 2 with 22. We have 9 over 11. And finally, we get, under the same LCM, 11 plus 9, which is 20 over 11. So the required sum is already calculated, and the result is 20 over 11. The end. Thanks for watching me. See you in the next few days with more and more interesting problems than this. Take care. God bless you.